In this video, I'm going to show you how to conceive, record, edit, and use a corpus. But first, what is a corpus? So a corpus is a collection of samples or a single long file that you might segment, or a combination of these things. It's generally some sort of collection of samples that you'll use in combination together. So for the purpose of this video, I'm going to be creating a corpus using banjo. Now in this case, I want to do percussive banjo, meaning that I'm not terribly interested in pitch, but something you want to consider when you're creating a corpus is having some cohesive musical language or sonic or timbral language that you want to limit the corpus to. And then within that, to think how granular and specific you want to be for every increment or sample that you capture. So for example, in this case, since I'm not interested in pitch, I'm not so fussed about getting every chromatic note out of it. But since I am interested in timbre, I will want to get some variety. But how much variety do I get? How many variations of loudness and timbre do I get per type of sound will be up to me as part of how granular I want the corpus to be. It can be an interesting aesthetic decision to have a very limited timbral language, and then you have a very fixed sonic world from the corpus, or if you have a much broader variety, you'll have something that's a little bit more nuanced. So it's a kind of an aesthetic decision for you to make. Generally speaking, you want to try to capture with more sources than you think you'll need. In this case, I'm going to use a pair of C214s as my close mics. I'm also going to use a DPA 4060 to capture some room omni mic type sounds. And I was considering using a contact microphone, but given that I want to get some percussive sounds, I do want the head to resonate quite a bit, so I don't want to dampen the head at all, so I may not use that, but I pulled it out just in case. Okay, so in this case, I'm thinking I'm going to have this as my main mic picking up directly center from the head. I'm going to have this one pointing a bit more to the edge of the head, see if that gets a bit more brightness. I'll adjust phase and see how that goes once I'm have the computer set up. And I've got the DPA clipped here to the body, which should definitely pick up a lot of the head type sounds and a little bit of the ambience from it. So from here, I'll just go into the computer. So here we are inside of Logic. You can use whatever DAW you feel comfortable recording in. Ultimately, we'll do our editing in Reaper, but for the recording part, use whatever you feel comfortable with. Now, just like with the microphones, you want to use more sources than you think you need. When you're recording, you want to record at a higher sample rate and bit depth that you typically do, just to make sure that if you're going to do any downsampling or further processing, that you have the highest quality recording as possible. So in Logic, this is actually in a couple different places. So for my audio, I will change the bit depth here. 24-bit is fine, 32-bit if you want to get extra fancy. And then for the sample rate, I will do that here. So I've set it to 96, which I think is fine for what I'm doing. But if you know that you're going to be downsampling the samples or downpitching the samples later on, go ahead and set this to 192 or 176. So with that, we're ready to record. So now I'm going to do the actual recording. I've got everything set up. I've got some preparations here. I'm going to go through and capture all the sounds, try to be as detailed as possible while keeping in mind the original prompt of, have some kind of sonic space for it. So I'm just going to record and I'll just speed through this as we go. Okay, here I am back in Logic. I've recorded about 12 minutes or so of audio. That should be good enough to work with here. So the first thing I'm going to do is I'm going to just do a basic mix, get some levels that I'm happy with, balance the mics in the amount that I'm happy with, and go from there. So I'll just pick somewhere. Okay, I've got a basic mix I'm happy with here. Just put some high passes on stuff, a little bit of fine-tuning EQ, and a little bit of dynamics. So what I'm going to go through now is I'm going to cut it up slightly and just edit out the large sections if there's any bits of me talking or large silences between things. Because once we get this over into Reaper, we want to be able to focus just on the onsense and not on the material that isn't audio. So I'll just spend some time and edit that stuff down a little bit. Okay, so I've trimmed this down to roughly the main bits where it begins and ends. There's still some adjustments in when I get different preparations from the middle, but I can deal with that in the in Reaper. So I'm going to bounce this out now, and I'm going to bounce it still at the higher sample rate, because that I want to have the option for later on. And if I'm going to do mono or anything, so I'm just going to bounce it at the full go right now. Okay, here I'm inside Reaper. I'm going to show you a sort of intermediate and an advanced way to do this. So the first thing I'm going to do is I'm going to take that banjo corpus that I bounced and just drag it right into Reaper. So here I've got it in Reaper. I'll scooch it over. So there's a couple things you want to make sure you have the snap disabled. Otherwise, it'll just quantize to bars when you go to do things. And that's the sort of all we really need to get started here. So the basic version here is I'm going to select the clip here and hit D to do this dynamic split. So this has a couple options. So by default, it's set here to transient, and you can see it selects all of the little slices there. You can see it's missed some here and it's missed some elsewhere, but you can see it more or less catches most of them. Now, if you want, you can also set this to when gate opens, and then you'll get a couple more things, and you can set a threshold here, and you can fine tune this to get everything up and running. You can play with both of these dials, and if you want to trim silence for the kind of sounds I'm working with here, I won't. But sometimes if you have a long delay between each sound, it could be useful to do that, and you can set the minimum slice length and the minimum silence length. Both of these will adjust the slicing, and you can see how the impact that it has on the background there. Reaper is quite good in the fact that it'll show you this as you go. So depending on what you need, you'll set that up. For the purposes of this one, I'm just going to set it up to, let's do this, and I'll set a pretty low threshold like that, and I'll set the minimum slice length, probably something like that, minimum silence. I guess it doesn't matter for this mode. So once that's done, you can see it's missed some, but that's fine. As long as you catch the bulk of stuff, you're good to go. So there I can then hit split. Now it's made this one entry a ton of entries. Okay, so I'll jump to the beginning here and select the first one. So what I do, and this can be quite tedious, is I'll go through and massage all of these. So here you can see it found this slice, but it detected it here. So if I wanted to, I can grab this and scooch it over there. And if I want to be real detailed, you can kind of zoom in and find that spot and just, okay, that looks like about right. If you want to get it at a zero crossing perfectly, that's good to go. And then what I do is I'll go to the next clip by doing the keyboard shortcut of Control Option Next. And this takes me to the next clip, in which I'll zoom in and I'll adjust it as need be, and then go to the next one and do the same. Okay, and it can be quite tedious, but I find this is a very good way to really fine tune things in. So in this one, this might actually be better over here. Actually, there might be about right. And then go through with them. Now, for those spaces where it missed some, so for example here, so this is likely an onset. Okay, so there I can hit select where I think there should be a slice and hit S. And that'll create a new slice at that position. And wherever I think there's slices, I can go ahead and slice. If I want to delete some, so let's say that this whole section is just fluff, I'll go ahead and delete that. And then you can go through here and just zoom in, slice, 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 and then I can, select it, go in close and adjust the thing here. So the basic version, well, I guess is the intermediate version, I'll go through and do this for every single slice. And then if I wanted to be a little bit more detailed with it, I can then trim where I think those sounds actually end, because I don't necessarily need a lot of, silence after each. So that's the basic version here. So let me undo a bunch and get back to the original file. There we go. Well, I'll just drag the file in again. So that'll get us going for, good amount of editing. As I said, it can be a little time consuming. All of these versions that I'm going to show you are going to be quite time consuming, but it is how you get the best results. So that's using the built-in slicing. Okay, so the next option is to use ReaCoMa. Okay, so ReaCoMa is an extension for Reaper by James Bradbury, where you can use the underlying FluCoMa algorithms, but inside Reaper. So you can basically get the same exact onset detection and segmenting that you can in FluCoMa, but inside Reaper, which is fantastic. So if you'll come here to this, I'll have this in the link in the video. You go through the wiki and just follow the steps to install. It changes for each version, so just go ahead and follow the steps for the installation. And once you've done that, in Reaper, if I go to Actions and I search in here, I can now put AMP Slice. Now, AMP Slice is the core onset detection algorithm that I use in Datanaught, and it's one of the fastest ones in FluCoMa. So if I select this here, it brings up this little window. There's quite a lot of parameters here to massage. I'm going to show you some settings that I think work really well. So these are the default settings that I would use in Datanaught for 44.1K. So these numbers are in samples, so the fast ramp up, fast ramp down, etc. The two numbers that we're going to massage the most are going to be these, but these numbers, I recommend setting them to this. However, since this file was recorded at 96K, all of these numbers that are in samples, I'm going to double. So rather than being 383, it's going to be 766, and then fast ramp up, etc., etc. Then along the bottom here, I can show you the on and off thresholds as they are for the sensitivity knob in Datanaught. So the default is this 19 and 8, but if you want it to be a little bit more sensitive, you can go that way. And if you want it to be less sensitive, we can adjust this on and off threshold accordingly. So I'm going to put these values in. So if you control click here, you can type the value in directly. So I'll put 766, and this goes to 6. And then both of these are 4,410. Then this I'm going to set to 19. This I'm going to set to 8. And I'll explain these values and what to do with them if you want to fine tune a little bit more. This should get you going to a decent place. Okay. So if you're curious about these values, you can check out the onset detection video. That'll go into them in a lot more detail. But ultimately, the two values we want to massage the most are this up and down threshold. So on and off, as they're labeled here. That'll set the threshold at which it turns on, and then the threshold at which it turns off. The floor and minimum slice length are also quite useful. This is how small a chunk it can be. So in this case, I can actually probably put this up a little bit more because I'm not playing terribly fast for these samples. So I'll just put this up to 3000. And the rest of the settings I'll leave the same, and then I'll click segment. Okay, so now if I zoom in, you can see that it's caught a lot more of it. There's still some spots that I can see where it's missed some attacks, but this gives me a much better starting off point. And if I go all the way to the beginning and select that first clip, you can see that the position that it found is a lot better than what the default segmentation was. So you can see that's pretty spot on. I might massage it a little bit here, but it's the dynamic split from Reaper had it way over here. So this gives me a much better jumping off point, and this will also catch much more of them. So if I jump through a bunch of them, you can see the segmentation of AMP Slice has gotten pretty good. Some of these, as I said, I might go through and still massage these. But yeah, I'll go through that and edit all of them. So once I've gone through and edited everything, so assume I've gone through and tweaked every single of these samples. So the next step is I'm going to select all of the files, come here to Item, and then go to Item Properties. What this will let us do is it'll let us apply batch features or batch controls to everything here. So for the most part, all I want to do is put a little bit of a fade out, and this will depend on the material we're working with. So this would be 100 milliseconds. So if I hit apply, you can see it's put a fade on all of these files there. Now, depending on what you need, on the file length, that could be longer or shorter. This gives you a good place to go. You can also adjust the curve. For the type of trimming we're doing, I wouldn't suggest putting a fade in, but if you wanted to put a little bit of a fade in at the start of each one, you can go do that as well. And that puts that little tiny fade in, but for what we're doing, I'll leave that be. So then you put a fade on everything. That'll make sure that ending of every file doesn't have a click. Now, once that's done, we have all of these files. They're all trimmed, well, assuming they're all trimmed, and they all have fades on them. I'm going to select them all again, or they should still be selected. And I'm going to come here to Batch File Item Converter. This is the main reason why we're using Reaper for this. So here I'm going to add selected media files. This will add all of them. And then here we have a lot of options for what we can do. So first thing I'm going to do is I'm going to select the folder. So here I put Banjo Corpus done. And then here we have this file name. So here I've put, because of how I want to name it, I've just called this Banjo. And then you have a ton of wildcards you can add here. So you can put the output format, the date and the time, computer information, etc., etc. The one that I find most useful and the way that they're formatted inside DataKnot is item number. So this will put Banjo dash, and then I'll put item number. So this will be 1, 2, 3, 4, 5, and so on. And this will do it for all of them. Then down here, because I'm going to bounce a corpus with this, I'm going to set this to 44.1. I'm going to bounce to mono because I don't need this to be stereo because I've mixed it stereo. And the rest I'll leave the same. I guess you turn on the dither and you can put on, different type of interpolation if you want, and normalize, etc., etc. So all of this looks good to me. I'm going to hit convert all. And you see it's going to go through here. And it's done all the files. So now if I go onto my desktop, I have this folder here that has all of these files. So Banjo 1 all the way to 3 to 6. Now, one thing I like to do just to make the file naming a little bit more consistent, because different types of operating systems will order this in a different way, is I like to make it a 4-digit integer for the appended bit. So I'm going to do this actually here in just Mac Finder. Is select all the files, rename. I'm going to rename dash to -0. And that'll just prepend a 0 at the start of everything. So we can see all of those are there. But everything below 100 could use another 0. So there's probably a better way to do this, but this is what I do and it works pretty well. So I want to select all of these. So from 1 to 99, I'll rename, do the same thing again. And now I have this. So now I have a new corpus with Banjo 00001 all the way to Banjo 0326. Okay, and all of these combined, we have 326 files. This is 43 megabytes. And now this is ready to analyze and deal with in DataKnot. So here we are inside of Max. Now I'm going to show you what you can do now that we've recorded and edited our corpus. The first option is to take the raw audio file, which I've now loaded into Max into this buffer here, and I'm going to use that to refer directly into Corpus Match. So this sidesteps the need to create an offline analysis. So I'll click refer there and let that run. It's a little bit of a slow process and it isn't nearly as accurate, but it does give us an option if you just have a corpus that you just want to use and test very quickly. So this will take maybe a minute or so to run through the analysis. Okay, now that it's done, I can go ahead and browse the corpus. And I can send audio into corpus-based matching. But you can see some of the editing isn't perfect. Sometimes it doesn't quite line up right. This is because it's using the onset detection and it's not exactly perfect because we didn't massage and fine-tune every single onset. So that's the first option, just referring it. Now, instead of that, if we want to create an offline analysis using the edited files that we made, I'll just open a new window here, click on the sidebar, and drag in a corpus create. So I'll read folder, and I'm going to point this to the folder of files that we bounced in the previous step. Hit open, and this will start analyzing. So you'll see it's running through the files here, and it gives you a progress report of how we're going. Depending on how long the files are, whether they're stereo or anything like that, this can take, and you can see here it's going to take like 20 seconds or so. This can take up to a few minutes if you have a really, really big corpus. Once it's done, it gives us some summary information about it. So it's about 400 samples, the minimum and max duration of them, and then some spectral kind of descriptor summaries of what it is. So I'm happy with that. I'm going to write this to the desktop. I'll just put my name here, Banjo Corpus, created during tutorial video. And the rest of the information you can put in here if you want. So I'll click that. I'm going to put this on I'll put it in the same folder, and I'll call this Banjo. You can name it whatever you want. So I'm going to get that out of the way. Now I'm going to come in here and I'm going to read that file that I just made. So I'll put it in here. And this one is just called Banjo. And that'll replace the referred one. And here we have the banjo. So we can see here, the 2D plot will give us a kind of clustering here. I've got the squeaky sounds. They're the kind of like low-pitched plucky sound. So once I have this loaded, I can just play this, so I can browse it just with my mouse or a gamepad or anything like that, just using the 2D plotter. This is very similar to the FluCoMa tutorial video where you create a 2D corpus browser. This gives us that option. Okay, so once it's loaded there, I can go ahead and start messing around with this. So let's say I want to select just types of sounds here. So a Corpus Match has a built-in filter. So we can filter by a bunch of different things. So for example, if I only want the quietest sounds. So if I do this, and this will give me only the sounds that are quieter than 40 dB, or sorry, negative 40 dB. Some of those still seem a little bright, but they all overall the quieter sounds. What if I want only the bright sounds? So in this case, ones where the centroid is above 80. All of the squeaks and squawks. It can be useful if you hit this info message. It gives you some of the mean of some of these things. So it can be useful to look at these. So okay, in this case, the mean of the centroid is 70. So with that, I can use that to base what my queries will be here for the filtering. Let's say I want time centroid where only sounds that sound short. So in this case, ones that sound where 10 milliseconds before that is half the energy of the sound. Okay, how about ones that are only longer than 1 second? Okay, and then I can combine the queries. So in this case, only bright and short sounds. All right, if I want to reset it. So this filtering is something you can do for both the 2D browser or doing it with the Corpus-based sampler. So what I'm going to do now is I'm going to send some audio analysis going into DK descriptors, and then that's finding the nearest match within the corpus. So that sounds like, let me just select somewhere in the middle. So that sounds kind of okay, but there's something with most corpus-based sampling that you want to consider. So in this case, I did a bunch of percussive banjo sounds. They're kind of on the bright side, kind of on the short side. The drums that I'm playing now in this audio recording may not necessarily line up in terms of like the overall dynamic range, the volume range, the centroid range, the pitch range, things like this. So it can be useful to use a setup, which is something that you do with a DK setup create, to scale the kind of dimensionality of the corpus. So if I click this setup here, now by default it enables it once you've loaded, but I'll explicitly enable it here, and I match that again. Maybe select a smaller section so we can hear the impact of it. So I get a wider range of sound. I'm getting some of the low sounds, some of the bright sounds. If I disable that just to compare, it's kind of getting stuck on that one strum sound just because that happens to be the nearest match within that. So generally speaking, you'll want to create a setup if you want if you have corpora that don't necessarily line up with your input. Okay, so that's working pretty well. Another thing you can do is you can affect the weight of different descriptors. So in this case, let me just play a bit of this. So that's sounding pretty good. But let's say I want the centroid to be more meaningful in the query. I can turn this up, and now that'll be 7 times more impactful in terms of the distance matching. In this case, it's kind of getting stuck on some of those ones because it's finding that more important than other things. So let's say I turn that down, but I want to care about the loudness a lot more. So in this case, it's finding those kind of quieter sounds. So you can use this to impact things. This is really useful if you have pitch-based material. Here, this is not very pitch-based, but I can turn some of those up, and let's say loudness. I don't care about loudness so much. Okay, so here's somewhere where you can fine-tune the type of querying that you're doing on specific material. So again, if you're doing some pitch material, that can be useful to turn that up. Or in this case, because it's percussive and the percussive input, I'm basically just adjusting the flavor of the matching that I'm getting. We also have an option here to do compensation. So what compensation does, it'll find the nearest match within that. And rather than playing back exactly the nearest match, if I turn this loudness compensation up, let's say the analysis that it did was negative 30 dB, and then the nearest match in the corpus was negative 35 dB, so it played that back. If I turn loudness compensation up, what this will do is it'll take that same sound, but it'll play it back 5 dB louder and to kind of more match it. So this gives us something where not only do we find the nearest match, but by applying the loudness compensation, we can then further apply the, in this case, the volume of the incoming signal. In general, what this does, it more exaggerates the dynamic range of what you're getting because you're finding the nearest matches within the corpus, but then further extending that to the input dynamic range. Similarly, for the spectral compensation, we're applying basically a matching EQ kind of thing, where it takes the mel bands of the corpus and the mel bands of the input, and then can apply spectral compensation. So if I turn this all the way up, in this case, both are quite similar, so it isn't a gigantic thing, but it can be also useful to invert these, where it'll apply the inverse of it. So if I have these fully cranked this way, if I invert both of them, that gives me a different sound and flavor. Again, in this case, they're both very percussive and both very similar sounds, but this can be useful for further matching the characteristics of the input sound with that of the corpus. And then finally, we have the pitch compensation here. What this one will do is it'll adjust the pitch of the playback to the pitch of what you're coming in. Now, in this case, because they're both relatively non-pitched, it's going to affect the tuning a bit more, where we'll get sort of faster and slower samples. So here some of them are playing back quite a bit faster. So that can be a useful way to get, again, a little bit of a wider thing. So if I crank all 3 of these up, that's giving me a quite exaggerated view of that. So the pitch compensation, depending on what you're doing, can be, useful or subtle or whatever. In this case, for the most part, I like the loudness compensation all the way up, and the spectral compensation maybe about 50%. That gives it a little bit of nuance, but without overpowering things. Okay, and here I'm going to show a little bit of an advanced setup. So I've got the same audio file just to compare apples to apples in terms of the examples we were listening to before. So here I have 2 corpus match. The one on the left has the toy piano loaded, and the one on the right has the banjo loaded. Within each, I'm also filtering the corpus. So on this left one, I have when the time centroid is greater than 100. So basically all long sounding sounds from the toy piano. So that's something like this. And on the right, I have when the time centroid is less than 10 milliseconds. So basically the short and plucky sounds. So I have 2 corpora loaded here, but then within them, I've also filtered it down to have specific subsets of sound within that. Now for the incoming audio descriptors, what I can use is DK filter to filter which types of descriptors I want to send to the left and which ones I want to send to the right. So if I put this here at greater than -45, only the louder sounds will go to the toy piano and the quieter sounds will go to the banjo. So that sounds something like this. Or I can make it so only the bright sounds go to the toy piano. which is a quite different bit of matching there. In this case, when pitch confidence is greater than 0.4. So in this one, there isn't a ton of pitch material, but there is some things that the algorithm determines as pitch. And then finally, in this case, when the centroid is high and the loudness is also high. So that gives us this. Okay, so that gives us a kind of a matching where we can set what corpus we're going to be using. And then within each corpus, we can also dynamically adjust the filtering. So you can get quite nuanced and quite detailed in terms of how you build the corpora up, what you match within them, and how you browse them, both in terms of your plotter and in terms of incoming audio. All right, so hopefully you found this video useful. In recap, we learned what a corpus is, how to conceive what kind of things you want to put in it, the steps to actually go about recording, editing, and processing the corpus to then using it in DataKnot.